Good day, everyone. And yet again, we are back. So we wanted to look at organic chemistry. I know that you've been working really hard to, ace those exams. Okay, so please, if you haven't subscribed to our channel, please just do the right thing and be part of the family. And I intend to dish out those very great lessons for you as we continue to prepare towards the exams. And by the way, for those of you who need assistance, either with mathematics or even with physical science, please, you're more than welcome to send me an email at info@mlungisinkosi.co.za. Okay, and we'd be more than willing to help you. All right, so today I wanted to just quickly look at a question where we are looking at reactions in organic chemistry. All right, so I picked this question particularly from it was the preparatory exams for the SCE exam that took place in March, April. Okay, so just quickly to look at it, and please don't be scared by these complicated type of diagrams that they give you. Okay, all that you need to do, you just need to know the type of reactions that take place in organic chemistry, and I think you'd be set. Okay, so let's just do the question together. However, what I want to do as an approach to this, I'm just going to quickly look at all the reactions that took place, and thereafter we're going to go to the questions, because in a way I want this to serve as a revision of the type of reactions that take place. Now if you look at let's take, so this would be at the center, right? They say the diagram below shows how the alkene can be used to prepare other organic compounds. All right, that is from letters A to G, represents rather different organic reactions. So if you look at this, so there's our alkene there. Okay, so that would be propene. All right, so in this case, in reaction A, can you see that we are going from an alkene to an alkane? That's propane. So in this case, this would definitely be an addition reaction, isn't it? And in particular, you would be adding hydrogen because you need those two hydrogens that are missing there. Okay, so to make it saturated. So in this case, that would be an addition reaction, and in particular, it would be hydrogenation, right? Okay, and looking at reaction B, so first of all, we don't know what compound Y is. However, let's look at this. If we take that alkene and react it with hydrogen chloride, okay, so what happens? You would, in fact, we would actually follow Markovnikov's rule here. So you'd be adding again hydrogen and chlorine, and the question is which one goes where? According to Markovnikov's rule, you remember that hydrogen would go to the carbon that has the most amount of hydrogens, right? So in this case, you'd have hydrogen coming to the first carbon here, okay, and chlorine would go to the second one for the major product, that is, okay. So in this case, this would be 2-chloropropane. Yeah, that would be 2-chloropropane, okay. Yeah, so it means if I were to move from propane to 2-chloropropane, in this case, I would have to add chlorine, right? So this would be halogenation, okay? And this one would be hydrohalogenation because you are now adding hydrogen and chlorine. Okay, let's go to reaction D. You see, very specifically, they are telling you that you have a major product there. Okay, so in this case, what would we have? Again, you are adding hydrogen and bromine. Okay, and in that particular case, it means that it would be an addition reaction. Okay, you'd form again 2-bromo propane, and the reaction D is actually the reverse of that, and so is reaction reaction C. It would be the reverse of that, right? So this would be an elimination reaction. So both reaction C and reaction D would be elimination reactions, and particularly there would be dehydrohalogenation. Why? Because you'd be removing a hydrogen as well as a halogen. Okay, Right. So if I look at the other reactions, so again, I'm now taking an alkene and I'm reacting it with water. Okay, so this definitely would be hydration. Okay, and the major product, remember the OH would go to the carbon that would have the lesser hydrogens. Okay, and the H would go to the carbon with the most hydrogen. So obviously the hydrogen would go to this carbon over here. So you would have you'd have two propanol, or you can say propan 2-ol, right? But the reverse of it, the opposite of it, in this case, that is reaction E, you would actually be moving from an alcohol to an alkene. So in that case, you would have dehydrogenation. Okay, so you'd be removing water there. And then looking at compound F, remember we had a haloalkane here. To now convert it to an alcohol, right? This would be hydrolysis, okay? And most of the time, or yeah, in most cases, you'd be using, sodium hydroxide to do that. Okay, so those are the reactions that you have, right? So what I want us to do quickly, let's look at the questions step by step. Okay, so I wanted just for you to get a sense of how to go about. Don't be alarmed by the complicated structure. Okay, just look at each reaction as it comes. Okay, so they say write down the type of reaction represented by A. Okay, so A, we are going from an unsaturated hydrocarbon to a saturated. We are adding hydrogen in this case, so that would be an addition reaction. Just in case if they were to ask what type of addition reaction it is, so in that case you'd need to see what you are adding. All right, so in this case you'd be adding hydrogen. So we know in question 4.4 4.1.1 we have an addition reaction. Okay, more specifically we are having this is hydrogenation, right? So this would be hydrogenation. We are adding hydrogen in that case. Okay, right, let's go for the second one. Okay, B. So what type of reaction is B? We are going from a saturated hydrocarbon. So what we are doing is we are reacting it with a halogen. Remember, we've got a haloalkane there, right? Because of that reaction there. So that tells us compound Y should be a haloalkane. So to go from an alkane to a haloalkane, in that case you'd have to add, it would be a substitution reaction. Okay, so in this case this would be substitution. Okay, that would be substitution. Remember, an alkane has got the maximum number of hydrogens. Okay, so the only way that it can react, and remember that alkanes are very stubborn. These guys don't like reacting very much. So what you would have to do to get this reaction to take place, they usually use UV light. Okay, yeah, so it is an endothermic reaction. It requires external energy to take place. All right, and then 4.1.3, okay, reaction E, which is that reaction there. We are moving from an alcohol to an alkene. All right, so in this case you are eliminating H2O. So in that case it would be an elimination reaction. Okay, elimination. Okay, right. I hope that you are still with me. Right, so they say write down the IUPAC name of compound X. Okay, so we are looking at this guy. Just as a bonus, I just wanted to just show you how that reaction would kind of look. Okay, so what you are taking is you've got this guy here. Okay, of course they didn't ask us to show it. They just wanted us to write down. So I just want to show you how this takes place. So I've got an alkene there which in this case is propene. Okay, so I am now going to react it with hydrogen bromide. Okay, so that's HBr. So remember, this is where we apply Markovnikov's rule. And just to show you what I mean by that, is that now you've got hydrogen and bromide. And remember, the double bond there, what happens on the other side is that we will break the double bond, okay? Right, so everything else remains as it was, right? But what we do is that we will break the double bond. And now remember, the moment you break that double bond, you know, I kind of showed in the videos that I produced on reactions of organic compounds. So if you think about that as a double bond, the moment you break that double bond, you've got now two bonds that are actually available, right? So if I break the second bond, rather, I should say, if I break the second bond called the pi bond, in this case, now I've got two arms available. There they are there. Right, now what could possibly happen is that I could have hydrogen here and bromide there, or I could have a bromide on the first carbon and hydrogen on the second carbon. So this is where the major product comes in, okay? Or the understanding of the major product. So what happens? We are going to apply Markovnikov's rule. And what does Markovnikov's rule say? Well, in this addition reaction, the hydrogen would tend to go to the carbon that has the most number of hydrogens. And which carbon is that? So between the two hydrogens, carbons rather, this one had one hydrogen, this one had two hydrogens. So in this case, you would have the hydrogen here, okay, going to this carbon with the most number. So you would end up with something like this. Okay, so this would be compound X. Okay, so compound X would be 2-bromo propane. Okay, that is the major product. Of course, the minor product would be the other way around. You'd have the bromide there, so it would be 1-bromo propane. Okay, right, I hope I've kind of answered 4.2. So 4.2, you didn't need, and by the way, they said write down the IUPAC name. Please, you didn't need to show the compound, all right? You just needed to show the name. So let's answer the examiner's question. And please, ladies and gents, it's important for you to follow the instructions of the examiner. So this would be 2-bromo, okay, propane. It's all one word. Okay, right. So let's go to the next one. So they say we've got 4.3.1 now for reaction D, wherein we are taking the haloalkane and we are now eliminating the hydrogen bromide there, right? Okay. So what we need to do is realize that we have actually removed hydrogen and bromide there, so definitely it's an elimination reaction. They want to know the type of elimination reaction that it is. So we removed hydrogen and bromide, so in this case it would be dehydro. So this would be dehydrohalogenation. Okay, so remember, all the elimination reactions have to start with a D there, right? And now they ask us to state the two reaction conditions that are needed. All right, so for this reaction to take place, the elimination reaction to take place, actually there are two things there that must take place. Okay, we use a concentrated strong base, so we must have sodium hydroxide, let's say, which is concentrated. Okay, and we must have high temperature. Okay, so delta H definitely greater than 0 there, right? So we say it's heated under reflux, by the way. reflux is just simply a method of reacting something, okay, just taking the vapor and just cooling it down later on, right? So yeah, those are the two reaction conditions. All right, so in this case we are okay, we are set. So on 4.4 they said write down the formula in an organic of an organic inorganic reactant, right, needed in reaction F. Now let's go and look at reaction F. So we would have a haloalkane rather, being changed into an alcohol, right? So you would use sodium hydroxide, okay? So for obviously for 4.4.1, that inorganic reactant that's needed is would be sodium hydroxide, okay? You can also mention H2O. You'd be able to achieve that using water. And then the last one, they say write down the balanced equation using structural formulae for reaction G. Okay, so reaction G, what we are doing is we are moving from that alcohol, right? Remember in reaction F, we would have formed that alcohol, and we said that alcohol would have been, all right, so if we consider that, so that would be two propanol, right? Or you can say propan 2-ol, right? Because what we would have done is eliminated that hydrogen, that bromide there in carbon number 2, and replace it with OH, right? For the alcohol. So you'd have 2-propanol, right? So in this case, let's write down the first reactant. Okay, so 4.2, and they said using structural formulae, right? So you would have here's our alcohol. All right, and how do I convert an alcohol? Please remember that compound Y is a haloalkane, right? So that means that you are converting an alcohol, so it would have an OH over there at carbon number 2, and we are converting it to a haloalkane. And which haloalkane will it be? Remember, when we moved from alkene to that haloalkane there, what we added was hydrogen chloride, right? So that means that we are now at compound Y. Compound Y would be 2-chloropropane, right? So what would I need to react that that alcohol in order to form 2-chloropropane? So I would need to, react it with probably hydrogen chloride. Okay, so we can take hydrogen chloride there. Okay, and what I would form on the, okay, let me just get this stuff out of here so that I create space. And what I would form on the other side is obviously, so now I'm going to replace the hydroxide ion with the chloride ion. So in this case, I would have on the other side, okay, so there it is. Remember, they said I must do this in structural formulae, right? So I'd have chlorine over there, okay, and I would actually have, okay, so I just want to have all of them plus, now what's left? Remember, you've just taken out OH there, you've taken away chlorine there, so what are you left with? H and OH. So obviously it means that you would also form H2O, water, right? And it doesn't matter whether you write water in this way or you want to write it in structural formulae form. Okay, in structural form, it would look something like that. Okay, right. So I hope that you are happy with this question, and obviously we'll try to do some more questions in the near future. Otherwise, thank you so much, ladies and gents, and I will be seeing you again next time. Sharp.